Hello, everyone. Hey. Well, actually, it looks like we've been thinking the same exact slides from a different angle, so we've been cheating from each other. And Peter, you may start a new prize by the end of the day for the number of times the word data was mentioned, because it looks like you will hear it a lot. My name is Ibrahim. I joined AVEVA Select Scandinavia a few months ago. Before that, I worked in the MES and PI fields as an architect, as an engineer, as a program manager, and a reseller also. So today we are talking about a journey that we all been talking about, the journey of data. What can we do with data? How much suffering do we have with data, and how to turn that into something more useful? I'll start with this scary slide, actually. And the scary slide is the 5% there, but I'll start from the other irrelevant part, which is an interesting one I found recently. Like 2/3 of the gold we have today in the world was mined only in the last 70 years. And in order to explain that, we can simply consider the innovation we had in the mining industry and the new technologies of extraction and the richness of the tools that we are using. Keeping that in mind, we try to do some sort of an analogy to the data that we have. And similar to that, 50% of the data that we have today was generated in the last 2 years. This was in 22, but I think it's the same comparison we're going with. So we have a huge amount of data. Each and every system, each and every IoT, each and every instrument is generating data. And the generation of data is not the challenge. The challenge is something else. We have something like 38 or 40% of data scientists' time being spent on doing data cleansing and organizing and classification of that data. That's a huge amount of time. And before the scary one, 80% of the data that we have is unstructured. Unstructured, like we have structured, which is time series databases, maybe relational databases, the data that we receive from the different OT, IT worlds. Unstructured is more like the videos, the Excel sheets, text files, emails, chats, maybe. We have a huge amount of unstructured data that is not easy to handle or deal with, and they take a huge amount of storage on our systems. And we need to think like how much richness of data that we can extract from that, similar to our friend in the gold there. And the scary one, which was really surprising to me, like 5% only is being properly utilized. So compare this 5% with 66% being already extracted. So we hope we can increase that 5%. And again, mentioning the word data and data, lots of people talk about data, and yesterday we heard the same thing a lot. And these are quotes, I'm not going to read them, but they all emphasize and highlight the significance of the value of data that we have today if we properly utilize it. I'm not going to read the negative ones that say like it's nothing and garbage in, garbage out. And that this data is the fuel of the century. It's the energy it's the gold that we are looking to extract. And the last sticky note is actually mine, and I've been preaching over the last 20 years the importance of transforming data into information, into knowledge, into wisdom, into insight, into action. Like, if we don't do this full cycle, then there's still something missing. And talking about the IoT and the OT and IT fields, we have on the left the lower level control layer of data, and the business enterprise data. And we have these pain points, which we all know about. Like we know that we have data trapped in silos. We have the inconsistency about tag naming. We have problems with propagating the data between the systems, integration of these data, interlinking. And the only way to handle this is connect these together. And connecting these together is not building an interface. As I said, I've been working with MES systems for a long time. And a long time ago, when we have this problem, a good programmer like me will go there and build a point-to-point interface. And then, there's something called middleware. So let's implement a middleware that sits in the middle and connect these boxes together. And then there's service-oriented architecture, which was like a big fuss at that time. So let's implement SOA. But the problem is not only about building an interface, it's making use of that exchange data and building context. Having that context understandable by both worlds of IT and OT, and even within the same OT boxes and IT boxes. And for that, we have our friend, the Pi data infrastructure, which I need to brag about it because I'm lucky to have started working with Pi since 1997. And since then, Pi has been evolving, and my admiration to Pi was like, I have worked with several other real-time databases, and I still like this one. So having implemented, or to implement such a system at the center or at the side, not necessarily actually, because we have in the layers like the control layer, and sometimes it's the Pi, usually IT and OT people might fight like Pi belongs to us or byte belongs to us. It doesn't matter much, but the idea is put it in place, have it doing the interconnection between the two worlds, and equip it with proper data, and it will turn those data, once the components are implemented, into actionable insights. So a question naturally might arise, why Pi? I asked that question myself when I started working with Pi. I saw the DCSs, like as David said, like I still remember the first day I entered the control room of a big refinery. I used to work in the Middle East in oil and gas. And they have these nice screens with lots of colorful beeping screens. And like they have it all. Why do they need another layer? And then at that time, the question, why Pi, can be answered different from nowadays. Why Pi at that time, someone will answer like, yeah, DCS is unable to have archiving for more than 3 days. I remember at that time on Unix and VMS systems, or even a week, or sometimes a week. It does not have those exception and compression techniques of the advanced layers. And what do I want to say? So we're talking about the answer 30 years ago. And actually, I asked the same question to Patrick Kennedy, the one who wrote Pi, in one of my trainings, why do we need Pi? And the answer was, with a smile, of course, is it's a robust, special purpose time series database that you will need once you install it, and you can feel the power of it. And I felt the power of it. By one time, in those early ages, for one of the clients, we needed to demonstrate the throughput that Pi can do. And it's a long story, actually, but in short, we had to disconnect save lots of simulated data, and then flush to the Pi server. And I still remember the number. It was something like 12 point something million record in a minute that has been filled into the Pi server. So this is the answer 30 years ago or more. The answer now is different, and we'll see that in the next slide with the timeline of Pi. The answer on the previous slide, having looked at this, is Pi now is not a historian. It's not an archiver, but it provides the contextual data infrastructure that you need to sit as central among those boxes of yours, IT and OT, and leave it, make it play or work there. This one I like because, as I said, I've been working with these MES and Pi systems for a long time, and actually I cannot see this screen. Oh, maybe. So this is the timeline that shows how smart was the Pi system evolving with time over the last 40 years, maybe. Live companies need to stay alive in order to stay. And we heard a lot about companies that were humongous and then just, because they just were blinded by not changing, and they died. Pi with AVEVA has been evolving for a long time, and they were coping up with the challenges, not only the industrial challenges, not only with the business challenges, and not only with the technological challenges. It was coping up with what you need and think ahead of how can we serve our partners and users and provide for the industry and provide for those visionary people who make standards and serve them. So one of my old shirts of OSI, they were bragging about, we create history, because that's what they did. It was only a historian, a good historian with some interfaces. A few years later, they built, like, we need to build more interfaces. They were proprietary interfaces or open interfaces like Modbus, OPC, and other stuff. And then thinking of the evolution of the evolution that Pi has been experiencing over the years. Early 2000s, they introduced Pi AF, which was a bit of a surprise to me. Like, this is a real-time database. Why would I need to install SQL Server for it? Especially SQL Server was not really that reliable at that time. But it proved that having that contextual metadata that is equipped with the Pi AF, the asset framework, was a really powerful thing, because we're not only talking about historian time series, we're equipping or adding the metadata, the hierarchical representation, the classification of data. And then they added, Pi AF itself took a few years actually to mature and provide the sought purpose of it, until the 2014, when they added the analytics to that. And then they added the event frames, open message formats, and actually there is a box missing there after AVEVA took over, where we have the big connect that we will talk by the last slide. So this timeline shows that in short, and the conclusion is the Pi system has been evolving over time, and it's thinking ahead on how to fulfill the needs and serve us. And for that, it needs to sit in the middle, or at the center, I would say, serve the OT layer, as we said there, by collecting those data from different instrumentation and tags, archive them, cleanse them, do proper exception, compression, and and save those and prepare them to be exchanged bidirectionally to the business layer, where for the first time we're talking about, after AF, talking about integration with the planning orders, marketing orders. Believe it or not, I don't know if anyone knows that 20 years ago, PI did not have a future timestamp. Like, I cannot save a value on PI that happened tomorrow. And that usually is possible, because if I want to have a marketing or a planning order, I can plan it for tomorrow, but I cannot save it. I think it was just a margin of 10 minutes. So AF was a powerful introduction for linking with the business systems. And they managed to provide for KPIs and doing the forecasting and support all of these systems. And it needs to sit in the middle, or at least between those. Again, the same picture, the same slide with some pictorial representation, like we're archiving or collecting lots of data, optimized and storing those data, and then adding context to it, transforming the thank you so much. Life is wonderful now. Transforming those data into actionable KPIs, and then adding the event frames, which were, as we said, there was AF, and then it took a few years to mature, to add the event frames. And the event frames were a big introduction to highlight the time windows and your operating modes, start, stop, it started here, it stopped here. Like, I have shutdown period here, I have these sequence of stops or starts with the event frames. And to make use of that data, we need to serve it to someone who is waiting for it impatiently through notifications in order to make actions. The industrial data platform is there to integrate edge to the cloud. We heard that several times over the last 2 days. And for PI sitting in the middle, we serve the left part, collecting all of those data, and we serve the use cases. Use cases I will talk about how do we start with a use case, but we have lots of use cases, needs. I'm living in a plant, and I have those pain points, if you remember, between the islands of data silos, and I need to serve and achieve something like, I need to do remote operations, I need to do enterprise visualization, I do analytics, I do business intelligence, I link or connect that with APIs to AI and ML. So I need to serve many, many use cases. And the idea is, again, serve it to someone who's impatiently waiting for it within the organization on different levels, from control room to engineering, to operation, to engineering, to production accounting, to management, to senior management, or with our friend Connect, which we'll talk about, outside the plant or outside the company, for the OEMs and for suppliers and for developers. Implementing PI, act small, think big. That's the right one. We need to think big and start small. So we have like 5 levels of implementation, where we start with gathering the data, the asset information, and implement asset framework. That's essential nowadays. Sorry. Because PI is no longer a historian, it's a data infrastructure. It's a platform, it's an ecosystem that needs to be present among all the players. And then with event frames, I have more richness of data to my system. And I need to serve those data through multiple levels or multiple layers of notifications, through email, SMS, use my mobile, and pop-ups. until I manage to serve the cloud and outside the organization level. Oh, I'm out of time. I still need some time. Sorry. So having done that, or if we manage to do that, we get to see all of these beautiful blocks achieved and materialized for you. Like you have a historian, you have the analytics, you have the asset framework and visualization, which is very important. And of course, the events and the data pipes to your outside system. UNS has been mentioned a few times, and PI needs to be compliant with the standards of data, of the standard data standards or industrial standards. And we know that PI, with the asset framework, is UNS compliant for the reasons that you can read there. And it even adds value by transforming those tags into contextual contextual assets and prepare for the next world of digital twin. PI Vision this is just a promotional slide because I like PI Vision, and we cannot talk about PI and the component of PI AF if we're not talking about PI Vision, because that's the frontier, that's the facet that you see. That's the web-based interface that runs on your mobile, in your PC, on your watch, maybe on any device where you can do monitoring and control. And it's a very powerful tool where you can edit, modify, and send your decisions or monitor data. And then comes our yellow friend with the Connect data services, which integrate all of these together and share. Share is the main word here, is share this among all the stakeholders within the organization and outside the organization. Quickly saying, just as David said, to start implementation of PI, we need to think big of all of these, but start small with pinpoint, highlight one pain point, see that I have a measurable impact out of that. I need to fix this, and in order to be successful, I need to achieve this. I define that and I start collecting data for that. I collect the data and organize those and show the momentum out of that, say, call it POC, and then scale up, add another use case, add another use case. So this is the optimum way of developing things. This is the last slide, I promise. The same talk, but in a graphical way. We need to start with our operational data, think, what do I need to do in a small way? Think big, but start with a small way. Collect those, define the context, generate insights and analytics, have the operational value materialized, and then, believe it or not, once the stakeholders, the people in your organization or outside, will see this value, they will think, oh, I have this use case, which actually I saw just last week with one of our clients. I have this use case, can we add it? So it goes again through the flywheel, and let's add this, and then the flywheel spins and spins, and we're having a rotation for more use cases, for more value. And as the last quote here, once you use it, sorry, the more people use it, the more valuable it becomes, and I would add to it, and it will keep spinning and spinning. This is all I have. Thank you.
Ibrahim, thank you very much.
Always. Thanks.
Stay with me here for a moment. No, stay with me.
Oh, sorry.
I think we're going to do a little bit of a different setting here. Peter, do we have a catch box now already available?
Cash box?
Catch box.
Catch. I put cash.
Yes, so we have hidden some caches here to find. Geocaching? No.
Yeah.
Anyways, there must be some questions, but I have one to start with. So you talked about Connect as an integration platform.
Yes.
there are other possibilities as well to integrate data to enterprise systems. What type of integration possibilities are there, but say outside the Connect portfolio?
Well, integration is, I used to be called, I had the title in my career life as integration manager, so I know how to answer this.
Yeah, I'm out.
As we said, PI started with historian, and then they felt the need to connect to ABB, Schneider, Honeywell, Metric, like lots of DCSs and IoT at that time. And they built proprietary interfaces, and then they thought like, oh, we need to have OPC to have an open OLE for process control. And then other interfaces like even Pi to Pi connectivity. So the integration or the interfacing actually to the low-level system, to the control system is no talk. Like it's there. We can think of it as a de facto. Yeah. It is there. And then they built the relational database interface through AF, so we can talk to the business layer, and with the Pi Vision and the the cloud, they can talk to the outside organizations or Pi servers like B2B stuff. And actually, that's not the whole story. It's not about integration here. It's not about interfacing. It's about having real context between the two systems. Not only data mapping, like NO is employee number. It's not like that. It's having that context, the knowledge of the details of this piece of data with this piece of data, and having them identified and connected all among the different players. So we can talk about for long about interfacing and integration, but yes, the idea is fully integratable.
Open, scalable, as it should be. Is there a question? Yes.
Hello. Thank you very much for 2 really good presentations.
Thank you.
And I have like 3 questions. I hope they are like distinct and easy to like cope with. So first question is...
Well, I work as business development now, so I can just forget I was an engineer. I can say like, I'll ask our guys.
Okay. But I think they're quite general. So is it built upon the historian database? Is it the foundation of Pi as well as AVEVA historian? So they have the same historical database? No.
I mean, the AVEVA guys can correct me if I'm wrong. As you saw in that timeline, Pi OSI was acquired in 2021. So since '85, Patrick Kennedy sat on his kitchen table and developed that time series, which I asked him about, and it evolved for 40 years. So Pi was acquired 4 or 5 years ago.
Okay.
And the historian was developed in parallel, and they can work together.
Okay, that will.
So we're not talking about exclusive or, like either or. They can live together, exchange data from each other.
Okay. Then if we see we just think about the use case. If you have a lot of data in the AVEVA historian and you use containers within the containers to clean your data and train your models, what will be the main benefit to include Pi in that ecosystem?
Contextualization. The historian is a historian, as we said, but the benefits of having Pi is building up to the asset framework where you can have event frames, time windows, startups and shutdowns, and any time window that you can think of, and connecting to Pi Vision and connect to the outside and piping with the outside organizations. So it's moving your data, historized data like the time sequence data, into more integrated, contextualized data among the different business systems.
Okay. And the last, do Pi include model drifting and model inference? So if you do your models, can you run them in Pi real time?
Models? Sorry,
model inference. You connect your model to your data in real time.
What models?
if you have any models, machine learning models, predictive models.
I can also.
Well, I didn't work in AI.
Okay,
if you saw, like, I tried to avoid going further because I didn't do that myself. So
I can answer that question for you. So the mathematical capabilities inside Pi are very limited, but this is where again Crosser comes into play. So the relationship we have. So I would say in the last years before Crosser was acquired by AVEVA, we already used that as the the calculation engine to execute models close to the edge. And now with Crosser being part of the family, it's a no-brainer. Yeah. All right. A final question in the back of the room.
Touch.
Good morning.
I have a question related to unified namespace because it can also provide more or less the same capabilities as we get from.
I cannot hear. Like, can you raise your voice, please?
Yeah, I have a question that is related to coexistence of AVEVA Pi and unified namespace. Because UNS can also provide the same capabilities that are coming out of Pi, like data contextualization and even equipment modeling. So how do you see that AVEVA Pi and UNS can coexist with each other?
Well, if I understand you right, UNS is not a product, it's a concept, it's a standard. So what we are saying here is the standards of UNS are compliant by the Pi server or the Pi system as an ecosystem. It's not like, it's just like we're saying that this system is ISA 95 compliant. So ISA 95 is not a product, it's just like there is a set of, actually many pages of standards, and we just say, checkbox, tick, 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 yes, we're compliant. So yes, the concept can coexist because this is a product that meets these standards and they're working together.
And if I can add one final thought there, because if people talk about unified namespace, I feel as it's my personal duty to, to answer that type of questions myself. The Pi system is actually, in my opinion, one of the best solutions for building this unified namespace. And the reason is that unfortunately on the internet, most, let's say, information available is build a UNS using an MQTT broker. Now, I yet have to come across a first data use case where we do not need historical data. And that's the big Achilles heel of an MQTT broker, because we still need to store that data somewhere, and then preferably in a data store which provides that historical access in context. And then we're back to the Pi system. So I think it's a really, really good question, because there is quite some confusion on the market, and I'm happy that AVEVA actually has a very, very good integrated answer to the unified namespace problem. All right, with that, give Ibrahim a hand. Thank you very much.
Thank you.